On our 2.1 notes, we will focus on three separate sections. First one will be function notation. What do I mean by function notation? Let's start with a random function f of x, and I say this is equal to 3x squared plus x minus 5. If I have this function, the first thing I will look for is f of negative 2. To find f of negative 2, I will say that f of negative 2 is equal to, all I have to do is plug in negative 2. That will be 3 times negative 2 squared plus negative 2 minus 5. And if you calculate it right, you will get 5. Now, beside f of negative 2, I can also ask you to find now f of a. To find f of a, just like you saw on your after party, all you have to do is plug in a, meaning 3 times a squared plus a minus 5. And of course, these parentheses are not really needed. For the next one, I will go ahead and look for f of x squared. F of x squared. All I have to do is plug in x squared for x, meaning 3 times x squared, everything still being squared, plus x squared minus 5. And if you simplify this, you get 3 times x to the power of 4 plus x squared minus 5. Let's keep going. This time I will look for f of a plus h. Again, just like on your after party. This is equal to 3 times a plus h, the whole thing squared, plus a plus h, let me go back to my function, minus 5. What if I now say 2 times f of x? 2f of x. What is 2f of x equal to? All you have to do is multiply everything by 2. That means 2 times 3x squared plus x minus 5. And if you multiply everything by 2, you get 6x squared plus 2x minus 10. Now, the last one, or before last, I'll find f of x minus 2. To find f of x minus 2, I will rewrite f of x first, meaning f of x minus 2 is equal to 3x squared plus x minus 5, that I subtract 2 again. That will be 3x squared plus x minus 5, actually minus 7 at the end. On your after party, I ask you to find f of x plus h. I ask you this, f of a plus h minus f of a over h. If you calculate it right, the same way you did on your after party, you probably notice it will be 6 times a plus 3h plus 1. You can check and do the calculation by yourself. The next thing I want to talk about is the piecewise function. A piecewise function is a function that is defined on 2 separate intervals. I will call that function g of x in this specific case, and g of x is equal to x squared if x is less than 0, and x plus 5 if x is greater or equal to 0. You see, it's defined on 2 different intervals. The first thing I will do is find f of, I will find f of 2. To find f of 2, I will plug in 2 into the one that is greater than 0. So here, that will be 2 plus 5, which is equal to 7. But if I'm looking for f of negative 3, I will plug in negative 3 into the first equation, which is negative 3 squared, which is equal to 9. Let's go ahead and talk now about finding the domain. To find the domain of a function, there are few restrictions. Let's start with y equals square root of x. The domain of the function y equals square root of x, you have to set the inside of the radical greater or equal to 0. We talked about this before. If I give you a function y equal to log base a of x, or you can also write as y equal the natural log of x, Well, x got to be greater than 0 because you cannot find the natural log of any negative number or the natural log of 0. For the function y equals 1 over x, you will say x must be different than 0. Let's go ahead and do 3 separate examples. The first example, I will call it A. For example 1, I will give myself f of x is equal to 1 over x squared minus x. Because it's a fraction, I will start by saying x squared minus x, which is the denominator, must be different than 0. And if you solve this one, you will end up with x is different than 0 and x is different than -1. If I want to write it as an interval, it's from -infinity till, by the way, it's +1, till 0, union 0 till 1, union 1 till infinity. One example for the natural. Let's start with the square root. Square root of 2x minus 3. This is very simple. All you got to do is say the inside of the radical, which is the radicand, must be greater or equal than 0. And if you solve it, you get x is greater or equal than 3 over 2. So it's from 3 over 2 till infinity. That will be the domain. And that's B. And the last one, which will be C, I will give you f of x is equal to x over square root of 1 minus x. This one is combining the two rules here. If I combine those two rules, I will have, well, it's on the bottom, so it will have 1 minus x cannot be equal to 0, but yet it's also inside a radical. So I will just say greater than 0. Or I can say 1 is greater than x. So my interval is from infinity till 1 with parentheses because it's greater. But I want to show you one more thing. The last example, let's talk about the natural log or a different radical. So I'll give you this. F of x is equal to square root of x squared minus 2x. Same concept. You will start by saying x squared minus 2x is greater than 0 or equal. Or you will factor the x minus 2 is greater or equal to 0. Now, from here, you got to use your test point. That goes from infinity to infinity. The two critical points here are 0 and 2. So 0 is here and 2 is here. So I will test. If I plug in 0, I end up with -2. So in between, I get a negative. Here I will get positive and positive. Since I'm looking for greater or equal, my solution is from infinity to 0 with a bracket, union, bracket again, 2 till infinity.